Everyone knows the first factorization, but do you know the second one? This one that's given over here. Okay, so on this video we'll try to make sense of the second factorization, and we'll just assume the fact that you know the first one, right? The first one we have been taught that in the high school, right? And using the first one we'll try to wrap second one, and second one seems more interesting and like more unique. So yeah, we have already learned that this thing over here is x plus y plus z, x square plus y square plus z square minus xy minus yz minus xz, right? So if you want to factorize this, like the approach would be to first factorize x cube plus y cube, and from there, okay, let me do this as well, because like some people might not have been introduced to this one. So yeah, and then after that we will go with the second one. So we know that x cube plus y cube is just x plus y whole cube minus 3xy x plus y, right? Plus z cube minus 3xyz. Now this formula should be obvious to you, because this formula, we get this formula from the expansion of x plus y whole cube. Because if you expand that, there's just x cube plus y cube plus 3x square y plus 3xy square. So we are just subtracting that 3x square y plus 3xy square. So now after you know this, again try to bring the cubes together, right? And 3xy x plus y minus 3xyz. Now again, if you use the same formula, this will just be a plus b whole cube minus 3ab a plus b, right? It's the same formula, a plus b whole cube minus 3b a plus b minus, this is 3xy x plus y minus 3xyz, right? So now this is just x plus y plus z whole cube minus, over here we have 3 times x plus y z times x plus y plus z, right? Over here also, if we take negative 3xy common, we will just have x plus y plus z, right? Okay, so now this is x plus y plus z whole cube minus, if you take 3 x plus y plus z common, so now this will just be, if you take negative 3 x plus y plus z common, over here you will just have xz plus yz, over here you will just have xy, right? So now if you want to take let's say x plus y plus z common, over here you will have x plus y plus z whole square minus 3 times xz plus yz plus xy. Now just take the square of this. If you take the square of that, it will just be x square plus y square plus z square plus 2xy plus 2yz plus 2xz minus 3xz minus 3yz minus 3xy. So this is x plus y plus z, x square plus y square plus z square minus xy minus yz minus xz. Okay, so yeah, we have got the first factorized form. But like in the first factorized form, this looks pretty like long and boring, right? So we want to factorize that too. So now our goal would be just to factorize second expression in the form where there is just x, y, and z only. So let's try to do that. X square plus y square plus z square minus xy minus yz minus xz. So usually to do the factorization, we want to take it to the form, let's say x square plus some number ax plus b, right? So that we can later on write this as sum of two numbers, this as product of two numbers. We can do that, right? So yeah, let's try to change the h to the same form. X square minus x, I have y plus z, plus we have y square minus yz plus z square. Now in the previous video I taught you how to factorize such expression. We'll first factorize that. Now the way was, even though this is not factorizable in the real numbers, right? we do have other numbers, right? We do have complex numbers. So for this one, I told you that we will use the cube roots of unity. So basically, there are three numbers whose cube is 1. So cube roots of unity. So of course one of them is 1 itself. So next one is, we call that as, let's say, omega 1, which is just negative 1 by 2, negative of root 3 by 2 times imaginary number I. And the third number was omega 2, which is negative 1 by 2 plus root 3 by 2I. So yeah, these three, when these are cubed, we get 1. So these are cube roots of unity. First one is real, but the second and third are complex. And we'll use the properties of cube roots of unity, like to use in the given expression, that if we sum these two, you might notice that the complex parts cancels out, and negative 1 by negative 1 by 2 is just negative 1. And yeah, if you take the product, you might notice that this is again 1 by 4 plus 3 by 4, that's just 1. So we'll use these properties of the cube roots of unity to factorize the second expression. So x square minus x times y plus z. So over here, if you use that, you will get y square. Now I can write negative 1 as omega 1 plus omega 2 yz, and then 1 as omega 1 omega 2 z square, right? Now the helpfulness of writing it in that form is, now we have y square plus omega 1 yz plus omega 2 yz plus omega 1 omega 2 z square, right? I can again write that as, now if I take y common, this is y plus omega 1 z. If I take omega 2 z common, this is again y plus omega 1 z, right? I can write this as x square minus x times y plus z, plus this is just y plus omega 1 z, y plus omega 2 z, right? And now how do I further factorize this? How do I further factorize this? Now, to factorize this, notice that over here, like, these are our sums, and I mean, this is the coefficient of x, like with the negative sign, and this is our product, right? So usually let's say if I have x square minus x times a plus b, and then if I have ab at the last, this can factorize as x minus a, x minus b, right? We want similar thing over here, but the problem is, if you just take sum of these two, we don't really get y plus z, right? Even if we take difference of these two, we don't really get that. But like, there's actually a way in which you can make that possible, right? And the way is, the way you can do it is, let's say, like, now this might not seem obvious at first, but okay, but yeah, okay. So let me first show you, and then it might be. Now what you can do is, let's say if you just introduce omega 1, right, and then omega 2 over here. Okay, if you introduce that, now the helpfulness of the introduction is, because we know that omega 1 times omega 2 is just 1, right? So you can do this. Now how this becomes helpful is, now this becomes omega 1 y plus omega 1 square z, and then this becomes omega 2 y plus omega 2 square z, right? Now if you try to take the sum of these two, now let's say these two are products. Now if we try to take the sum a plus b, this will exactly be this expression over here. So if you want to see, let me show you that the sum is exactly that expression over here. So if I take omega 1 y plus omega 1 square z plus omega 2 y plus omega 2 square z, right? Now this is just omega 1 y plus omega 2 y plus omega 1 square z plus omega 2 square z. Now I want you to notice something, that actually if you take square of any one cube root of unity, you will get the other cube root of unity. That's a property of the cube roots of unity, and that seems to be helpful over here, right? You can verify that for yourself. So over here also, Now this is omega 1 plus omega 2y. Now this is just omega 2 plus second one is just omega 1 z. Now we know that sum is just negative 1. So negative 1 y plus negative 1 z. So this is negative y negative z. Right? It is exactly what over here, what we have over here. Negative times y plus z. So it's the same thing, right? Negative times y plus z. Okay, so now since we know that their sum is exactly what we have over here, I can write it as I can now write this as x square plus x times that sum omega 1 y plus omega 1 square z plus omega 2 y plus omega 2 square z, right? And then this product omega 1 y plus omega 1 square z omega 2 y plus omega 2 square z. Okay, so now let's try to factorize this. Let me try to take x common. This will be x plus this will just be omega 1 y plus omega 1 squared z, right? And over here, if I take okay, in this two expression, if I take, first of all, I should have distributed the x, right? And that would have made more sense. Okay, let me do that. Okay, so first of all, let me just distribute the x among them. So x square plus x times. Also, I know that omega 1 square is just omega 2, so let me write omega 2 z plus again x times omega 2y, and let me erase this portion over here. I'm sorry guys for the lag of space. Let me erase this portion over here. Okay, so omega 2y plus this is omega 1z plus this is omega 1y plus omega 2z omega 2y plus omega 1z. Okay, so now this, if I take x common, this is x plus omega 1 y plus omega 2 z plus, if I take omega 2 y plus omega 1 z common over here, what I get is x plus I took omega 2 y plus omega 1 z common, so this is omega 1 y plus omega 2 z, right? Now again, if I take x plus omega 1 y plus omega 2 z common, I have x over here and then omega 2y plus omega 1 z over here. Note that these coefficients of y and z are just interchanged with each other, right? So initially y had omega 1, but now y had omega 2. Z has omega 2, but now z has omega 1. So yeah. So now we have factorized the second expression. So now I can write this as x plus y plus z, x plus omega 1 y plus omega 2 z, x plus omega 2 y plus omega 1 z, right? Now if I like just suppose omega 1 as just omega 2 will just be omega square, and yeah, so that's what the required form over here is. So this is the same form actually, x plus y plus z, and if I say omega square as omega 2y plus omega 1 z, and then x plus omega 1 y plus omega 2 z, and our factorization is proved. So this was definitely slightly tiresome maybe later on, right? But yeah, we proved it, and this is a beautiful result. So I guess now you might want to show it to your friends or to your teachers, right? And yeah, just do give them a surprise. This is a really beautiful result. Hope you would enjoy with it. Thanks for watching and look forward to seeing you in the upcoming videos too.